Welcome back, and this is Patralik Satyam, and in today's video we'll be talking about machine learning. Machine learning is a subset of AI which is focusing on the concept that machines can learn by themselves from data. So till now, or in the past, we were we were writing programs for the machines to do a specific task. But now with machine learning, we provide a set of data to machine, and then machine goes and explores the data and learns by itself, and then it can do tasks that we want it to do. Sounds a little not so intuitive, right? But yes, it is happening, and we'll get to the how part in a much later video. For now, we'll see what are the different types of machine learning. And the first one is supervised learning, as you can see on the board. So we have broadly, we have three different types of machine learning. The first one is supervised. The second one is unsupervised. And the third one is a reinforcement learning. Now, what are these three? Right? First, let me throw a couple of more terms at you, and then we'll get into it and explain that. So, supervised learning, we do it on a labeled data set. Here in unsupervised, it is unlabeled. Reinforcement is slightly different, and I'll talk about it in a bit. Now let's look at what is labeled data set and what is unlabeled data set. Let me take an example. Halloween is approaching, and either as kids or now as parents, you must have seen kids going out for trick or treat, and they come back with a lot of candies, right? A bag full of candies. So imagine, either it's your kid or younger brother or sister or someone, and they come back with a lot of candies. Now you want to help them sort the candies. Okay, so what do? You sit with them, and you have all the candies there, and you say, okay, these are chocolates. Okay, these are Sour Patches, and these are say cookies, etc., etc., right? So you show the kid that these are chocolates, and you show them that you pick 5 of them, you place it here. You pick 5 Sour Patches, you put it here. 5 cookies, you put it here. Now this is what is labeled data. So now the kid, or in our case it will be the machine will know that, okay, these are chocolates. So we show them the chocolate and we say that this is a chocolate, this is a Sour Patch, and this is a cookie. Now the next thing, so you had a huge bag of all these candies and chocolates and cookies, everything here. So out of that, you picked up 5. You said, this is chocolate. You picked Sour Patches and you picked cookies. Now, from this remaining set, when you ask the kid to pick and put in one of these categories, they know which one is a chocolate, right? So they'll be able to do that. Now, you taught it with some labeled data, and then for the remaining task, the machine or the kid is able to do this. So this kind of learning is being done with labeled data, and here you're supervising, you're saying you're teaching the machine that, this is chocolate and this is Sour Patch and this is cookie. So this type of learning is called supervised learning. Now let's look at what is unsupervised learning. Now let me take another example in which there's a kid and he is going to the school, might be for the first time, or to a new school. What do? You go, you drop the kid goes inside the school and you return back. Now the kid is among so many students, right? The boys, girls, good, bad, from different places, different parts of the country, speaking different languages, and also, of course, there will be a common language in which they will be speaking. But they all will have their own traits, right? I'll just create dots to signify that these are, different students. Now, in this, whole, group of students, there might be 50, 60, 80 in their class. There might be another such sections. Say the kid is in 6th grade. So they will have their own section in which they will have 50, 60, 70 people, or might be 20. And then they will have several other sections for the same grade, that is 6th. And they all will have a similar number of students. And then there will be class grade 7th, grade 8th, 9th, 10th, etc., etc. So it's like they are in a huge pool of so many students. Now you are not with the kid to teach them anything here, right? But they start finding out patterns that, okay, I will love to be with this kid, this kid, this kid, and this kid, right? So what did your son or daughter do? They figured out from this whole set of data, they figured out a pattern that, okay, she likes basketball, he likes basketball, she likes basketball, and she likes basketball, and that is how this kid loves basketball. So it was able to figure out. And now what you see is in this whole big group, these kids have formed their own small group, right? And they walk along together, they play together, they sit together, they spend most of the time together, not with the rest of them, right? So here, this kid learned looking at the data, exploring the whole pattern, and figuring out what is it that this kid will like. So very similar in case of machine learning, unsupervised machine learning. We give a huge set of data to the machine. The machine goes through all the data and then figures out patterns in them, right? So let me take an example where we used unsupervised learning a lot. Typically in market segmentation, grouping customers by similar buying patterns and stuff. Say for example, Amazon or Netflix, their recommender engine, right? So what we do is we give all the data, so all these recommender engines the grouping of customers by similar buying patterns. So this is done in this way. The machine is sitting on, or your algorithm is sitting on that huge data set. It goes, it explores, and it figures out, okay, this set of customer is one category. There's no label to that. They don't know what that is, but they know that these are similar. And now if I am similar to this group, if this group likes something, I might like it. And that is how it will make a recommendation to me, because it's getting popular in a category where I belong. right? So there's no name to that specific group. It is unlabeled, but it is a group, and the machine found it out by itself. It was not specifically told that, you know, this is a group and I should belong to this group. So all those kind of things are being done under the unsupervised learning, right? And we will come to the sub-classifications and what kind of problems are being solved by each of these different learning types. But that will again be in the next video or one of the following videos. Now, what is reinforcement learning? So this is something you know, we all have gone through. If you score good marks, you know, you get rewarded, and if you do something wrong, you get a penalty or you're corrected, right? So in a very similar way, the reinforcement learning is a very similar kind of concept for the machines, right? So any kind of decision making in a sequential data, or training a robot to navigate a maze, or teaching a machine to play chess, or the self-driving cars. So all those things are based on reinforcement learning. So we let the machine make a decision or a choice, and then if the choice is correct, we give it a reward. If the choice is wrong, we correct it or we give it a penalty, right? So that is how we keep correcting the machine, and the machine now starts learning with its right moves and the wrong moves, and that is how we are reinforcing that learning on the machine. So that is what reinforcement learning is. Okay, so now let's look at the subtypes of supervised, unsupervised, and regression machine learning types, and also what type of problems it solves. So first, we'll look at the subcategories of supervised learning. Basically, there are of two types. One is the classification, and the second one is regression. So first is classification, and the second one is regression. In classification, we solve issues like you know, spam detection. So we tell the machine that these are the different types of mails. In these mails, these are spams, these are not spams, and then based on that learning, for any of the new emails that come in, the machine will predict whether it is a spam or it is not a spam. Or you know, any kind of diagnostics or customer retention or image classification. So I'll just put in a few here, like image classification, spam detection, we can also say identity and fraud detection. So all these things, identity and fraud detection, right? So all these fall under the classification. And then we have regression, or actually let me write it, bring it here, or let me use another color for this. So the other one is regression. And in regression, we do several you know, forecastings. Say, for example, you want to do a weather forecast. So this is a regression, we are bringing it here. So weather forecast. you can say market forecast. Life expectancy. So if you're trying to measure what will be the life expectancy of people, say, living in India. So life expectancy, forecasting or estimation. So any of these kind of predictions will all come under regression, which is another type of supervised learning. So this classification is the first one, and regression is the second one. In classification, we classify things, whether it is a spam or it is not a spam, right? Whether this is a cat or this is not a cat. Whether it is this is the right person or not, is it a fraud or it's not a fraud. So all those things go under classification, and under regression we have all these forecasts, weather forecasts, market forecasts, life expectancy, and things like that. So that is about supervised learning. Since I don't have space here, I'll just wipe it out, and then we'll come to the unsupervised learning subtypes and their where or what kind of problems they are solving. So unsupervised learning is now of two different types, right? The first one is clustering, which we already touched upon. So number one is clustering. And the second one is dimensionality reduction. So reducing the dimensions. What that is, it's a very interesting thing, and we will be working on that in one of the later videos in depth. But for now, just I'll give a one-liner explanation and hope that at least tells you what that is. So dimensionality reduction. Right. So these are the two broad categories of unsupervised learning. The first one is clustering, and second one is dimensionality reduction. Now let's look at what kind of problems they solve. So clustering, as we have already seen, say for example the recommendation engine, right? So Netflix recommendation engine and all those stuff, right? So it identifies a cluster, and then based on that clustering it can do several things. Second is target marketing. Again, in target marketing, you are again doing a very similar thing. You are identifying the right set of customers whom or prospective customers whom you want to send a particular marketing campaign. So that is again a clustering issue. We have customer segmentation, right? Or looking at similar buying patterns among customers. So all those things will be solved by this clustering, right? And that is one of the major subtypes of unsupervised learning. Now in dimensionality reduction, again we'll not be touching in details the dimensionality reduction, but What happens is, say you have a huge table, right? With might be 50 different columns, or might be even more. Sometimes you'll see databases having up to 100, or sometimes even more than that. So many columns are there. Now all the columns, obviously they are there for something, but for a particular problem that you're solving, might be you don't need all of that. You just need a few of those columns, or might be there is a way to combine multiple columns into one and give you a more meaningful information, and that is what comes under this dimensionality reduction. So I'll just take a very small example, although this might not be the absolutely right example, but it will help you understand what I mean here. Say for example, you have a table. In this table you have something, and this is for a say Zillow or Redfin or something like that, where you have area or city. You have how many bedroom flat or house that is, so a number of bedrooms, and or might be it's just the square foot. So, and it might be bedroom also. It will definitely have bedroom, bathroom, etc, 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 and then it will be the selling price of that, right? So it has bedroom, it has number of bath, floors, etc, etc. So a lot of things are here, but might be if I try to look at all that, it will be really difficult for me to understand, right? Now if I reduce a lot of these things, or not reduce, I reduce the dimensions, which is like too many here, and I just have something like per square foot. So I remove all these things and I say I reduce the dimension, and I say I have per square foot price, right? So it is like city and then per square foot price. Now I have just two columns, and then I get a good view of what are the property prices in that city. So that is one kind of example for dimensionality reduction. Again, this might not be the best or the most accurate example, but that is what it means by reducing the dimensions. Now, it can, so there are a lot of problem types that we solve with this. First one is meaningful compression. Note, this meaningful is very important here. It's not that we just compress it. It has to be meaningful, right? We have something called structure discovery. Then we have something like feature elicitation. So all these problems are solved by dimensionality reduction, and that is another type of unsupervised learning. Now we'll be moving on to the last one, and again I will delete, or I'll erase this, and we'll look at what are the subtypes of reinforcement learning, or rather what kind of problems reinforcement learning solves for us. So I don't have any subclasses now. Reinforcement learning is very interesting, but I'll be covering that in a later video at a greater depth. So right now let's just look at different types of problems that reinforcement learning can solve. So one is real-time problem solving. The second one would be any kind of skill acquisition. Third would be any of the gaming related things. Right. So and we have looked at some of those, like self-driving cars and stuff. So that brings me to the end of this session, and these are the different types and subtypes of machine learning algorithms that we commonly use. It's not the exhaustive list. It's just at the surface, and I hope you were able to get a grasp of what these are and how we can use them. I'll see you again in my next video where we'll cover some more of these technical jargons that will help you get comfortable with the artificial intelligence and machine learning. And this is Patralik Satyam. Thanks for watching.